Hello everyone, welcome to our 17th R&D session. I am Monica Fernandes from EDP New, and EDP New is the R&D center of EDP, and we have been organizing these webinars that we called R&D sessions since last year, where we basically explore different topics in the energy sector. We already talked about different topics from hydrogen, battery storage, floating offshore wind. And for today's session, we bring to the table the topic of smart buildings. My colleague João Bravo Dias will already explain you the agenda of this webinar, but basically we have some we will introduce the topic and then we'll have some time to discuss some questions. So feel free to ask all your questions in the Q&A tab because in the end we'll have some time to answer to your questions. And without further ado, I wish you a great session and I pass the screen to my colleague João Bravo Dias. Thanks.
Welcome everyone to this R&D session. Today we'll focus on smart building, as Monica said. As we are aware, the building stock is one of the major energy consumers, and thus the environmental goals of the European Union have been increasingly focusing on the importance of this topic on a way to reduce these emissions. A way to decarbonize this sector and reduce the energy consumed is to the increase of energy efficiency in the building, and for the building stock, this is key. Different strategies could be used to achieve these goals. The ones more simple focus on basic retrofits, and the ones more complex that we can call them smart, focus on monitoring, automation, machine learning, and artificial intelligence. Today we'll explore these topics with three speakers. The first presentation will be done by Felipe Neves Silva, which will focus on an ongoing H2020 project called SATO, which is being running for the past year and EDP New is part of. And the objective is to show how the increase of smarting of existing buildings can be done using different techniques and machine learning and smartization and increase the sensorization of buildings. Then we'll have Pedro Ferreira, which will show us how machine learning could be used for building energy assessments towards smart buildings. And finally, we'll have Manuel Casquiço, which will enlighten us on what is happening on public administration, more specifically on what are the retrofits plans and the reality in Portugal. In summary, we'll go from the future, what's going to happen in the near future in the building stock, to the current reality. In the end, we'll also have 30 minutes to discuss in the Q&A section, where we can explore and understand the gap between these two worlds, and where you can also ask the questions, as Monica said previously. Just a quick introduction to our speakers. First, we'll have and started his career at ISQ. He's been working, he started working as a research engineer in ISQ, where he worked in European projects focusing on auditing and monitoring of buildings. Then he moved to ADEN, where he worked in energy and water efficiency, mobility and circular economy. And since the beginning of 2001, he joined NEW as an R&D engineering and has been working in H2020 projects, focusing on smart buildings and cities. Then we'll have Pedro Ferreira, who has a degree in system engineering and computing and a PhD in electronics engineering and computing. He worked as a researcher and a professor in Algarve University, and in 2007 and 2008 he worked in the UK under a Marie Curie Research Fellow. Afterward, he joined the Faculty of Science of University of Lisbon, and he's been working as a professor and a researcher, being now associated professor. His main research topic focus on computational and artificial intelligence methods, artificial neural networks, or prediction forecast methods, among others. He has been applying these methods to energy systems and more concretely on smart buildings, where he is project manager of the H2020 project that Felipe will present. Finally, we have Manuel Casquiço, which has a degree in civil engineering and a post-graduation on management and business strategy. Since 2001, he started working on several companies, construction companies, and in 2007, he joined ADEN building department as an energy auditor. Manuel developed and coordinated several projects on energy efficiency, and since 2017, he developed a tool called Poupa Energia that helped consumers understand the liberalized energy markets. Currently, Manuel is the head of programs and initiatives in the department, where his main mission is to disseminate data and statistical information on energy sector and help consumers understand energy efficiency. So I will pass the floor to my colleague, Felipe Silva, so he can present Sato.
Hello, everyone. Hope that you can see me now. And the presentation. Yeah, I think everything's okay. So hello, thank you, João, for the introduction. As João said, I'll be presenting today SATU project. So the SATU project is a project funded by the Horizon 2020 program, and it's an acronym for self-assessment towards optimization of building energy. So before going into detail on the project, I would like just to show you who we are. And the project is composed of 16 partners from 7 different countries. And as you can see, we have 6 different partners from Portugal. One of them is EDP New, but we also have 2 linked third parties, which are EDP Comercial and the Smart Energy Lab. So we have 3 companies that are related with the EDP universe working in this project. So what was the challenge? What motivated this project? The first thing is that the buildings and building construction sectors are responsible for over 1/3 of the global final energy consumption. So it's a challenge that we have to decrease this number and make buildings more efficient. And the second challenge is that it was identified that in the European Union, most building managers and building occupants are unable to assess what's their energy consumption. So there is a need for more monitoring systems and more systems that can enable us to assess energy consumption. So what's our vision? It's exactly to respond to these issues. And by that, we'll develop in this project an interoperable platform for smart buildings. And you can see in this diagram, you can see the architecture of this platform. Basically, you can see that the building is in the center of this architecture. So it's a building and the user. So it's a user-centric approach. And by its side, you can see that we have an interface. So this interface aims to provide something similar to what we are used to with IoT platforms, but with some additional features, namely nudging techniques and also a feedback loop that will aim to increase energy efficiency. And as you can see here, we have this modular approach where we can add different layers to this platform. One very important layer of this platform is the integration part. So is where we collect and integrate data from multiple sources, so we can integrate from different legacy systems. One of them being EDP Ready system from EDP Comercial. And then we have all the other layers that can work with this data, namely the self-assessment, self-optimization, and the flexibility. So let's take a look into these layers and see some more details about them. So we can see them through the use cases or the set of actions that will run during the project. We divided them in 5 different areas. The first area is the monitoring. So it's the most basic area but at the same time is the most important, because we know that we can't manage what we don't measure. So it's very important to have these measurements in order to support all the other activities in the project. Then we have the second area. I will not go into much detail because I think this will be covered in the second presentation. But in short, the self-assessment is like a diagnosis tool that will identify underperformance in the buildings and will enable to develop strategies to correct the issues that were identified. Still, in this second area, we have benchmarking, because it has a similar goal, although it works a bit differently. So here what we aim to do is to collect data on different buildings, and by doing this and matching the buildings with similar use, we can identify the best practices in the buildings that perform better, and we can replicate those best practices for the buildings that don't perform so well. For example, we can identify malfunctions in equipment or inefficient behaviors, between other things. Then we have the third area, which is the visualization. I spoke a little bit about the visualization on the web or mobile interface. So this will be a bit closer to what we are used to nowadays with the apps that allow us to manage the smart buildings. Although we aim also to provide some features of nudging, for example, as I told you, and also this feedback loop that I spoke about before, that aims to improve the decision making of the smart part of the platform. Also, we aim to have another interface that is based on a building information model. So this is a very visual interface where it can visualize the building in 3D and also see where the energy is flowing. And we hope that we can use this type of interface to support other activities such as predictive or corrective maintenance. Then our fourth area is the self-optimization. So this is probably one of the most complex, along with the self-assessment of the areas that we have. So here is where a part of the brain of the system works and develops the strategies that will be implemented in the buildings. The main goal, as the name says, is to optimize the energy efficiency of the building, but then we also want to improve indoor air quality and occupant comfort. Besides this, in this area, when we look at it, we look into more specific and detailed strategies. Some examples can be, for example, to provide flexibility services to the grid, which is not a very short-term thing that we can accomplish, but is a study that we will make. But also we can look into other strategies such as load shifting by controlling some loads that have flexibility, using natural ventilation, using techniques of building as a battery. And at the end, all these techniques and strategies defined will merge onto a system that will evaluate the techniques based on on preset rules, and will decide what's the optimal strategy to implement. So finally, the final area that we have here in the project that we'll implement is the controlling, and here is just to implement the strategy that was decided previously in the buildings using the actuators. So finally, before finishing my presentation, I'll just like to show you two more things. And one thing is where we will test these features. And I'll just highlight the Seychelles residential pilot, because it's the pilot that us, EDP, will be most active on. So this is very important. We'll deploy ready systems in these pilots and we'll test all these features. And also, if you live in Seychelles, I'll leave you the invitation to contact us, because we might be interested in working with you. And Finally, the last thing that I would want to share with you is just 3 points on what's in it for EDP, what we aim to achieve with this project. So obviously we have this, we are co-developing this decision-making layer that can be applied over legacy monitoring systems. So we aim that by the end of the project, we can develop new services that can be provided to residential and commercial customers regarding this intelligent and smart buildings area. Also, we are gaining some knowledge on the indoor environmental quality and the parameters we need to assess and monitor to improve user comfort. And finally, I just highlight the evaluation of the appliance flexibility potential. Like I said, this is more a feasibility study that will gather loads from the different buildings and see if in a future market there would be room to play with this flexibility. And that's it from my side. Thank you very much. And if you have questions about this project, feel free to leave them in the Q&A section. Thank you.
Thank you, Flip. We'll now move on to another presentation from Pedro Ferreira, which will focus on the machine learning for building energy assessments. And this presentation will also touch a bit on the methods that are being applied to SATO, since Pedro is also working on this topic, as I mentioned previously. So the word to you, Pedro.
Pedro, we can't hear you.
I was muted. I always forget. Now
it's
do
okay.
you hear? It's
Yeah.
okay now?
Yeah.
Okay. Because in my screen it still shows as I'm muted, as if I was muted. Anyway, if you can hear me, then it's fine. Do you see the screen, the first slide of the presentation? I shared the screen. I hope it shows well.
Yeah, it's perfect.
Okay. So good afternoon to everyone. First of all, I want to thank João for the nice introduction and the picture that now has maybe 15 or 20 years. Anyway, I'm here to continue a bit the presentation of the SATO project, but now focusing on general ideas on how machine learning can be used for buildings energy assessment. First, let's look at what motivates us, and Philippe already touched this point. It is clear that we need to reduce building energy demand. And one way to do that is to have a better picture of how much energy buildings are consuming, and being able to do that dynamically and continuously in time. If we have better energy assessments telling us how much and how the energy is being consumed, then managers, building managers and occupants, owners, they can all make better energy decisions so that we can actually achieve this goal of reducing energy demand in buildings. And this is somehow a big challenge, because the real life energy consumption quite often exceeds the design, the building design, and even the equipment design predictions by more, sometimes by more than 100%. It's true that now we had energy performance certificates that provide an idea of how much a building, how it will behave. We also have energy labels for appliances and some equipment. We have eco design regulations. But to be able to assess buildings' energy continuously and in a way that expresses the real life performance of the building and of the building equipment, we need now to go beyond these static certificates and eco design regulations and energy labels. So the goal in the project is to provide the means to assess energy and then optimize energy use. So it's assess for optimization. And now, what is the potential of machine learning to achieve this objective, both in the assessment part as well as in the optimization part? Well, where does this potential come from? Of course, the energy transition process brings digitalization to the energy sector. It also brought decentralization, both in terms of energy resources providers, business models, data sources. Importantly, it involved different users and stakeholders and connected them. And this means that through this process, we now have abundance of data. We can have, it's not that we have sometimes, but we can have abundance of data related to energy and to energy in buildings. And of course, we have new problems and higher complexity problems. And this is why machine learning can be or can give an important contribution for the assessment and optimization of energy in buildings. Because we have different problems with all this decentralization, with the involvement of different users and stakeholders, and with important goals that the European Union has on this respect. And of course, these problems are more complex than they were in the past because of all the relations between them. But we'll go there in a few moments. We need just a small note because machine learning is not alone in this process, and it's only possible to use it for this objective, mainly because of two other contributions or components: the Internet of Things and cloud computing. Internet of Things brings us connectivity so that we can connect all the devices, all the equipment in the building, sensors, technical building equipment, everything that is consuming energy. Potentially, we can connect it to a network. And then we can have data flowing from these devices to a cloud. And that's where cloud computing comes in, because it can centralize data for a building zone, so we can structure our data in many different ways. And it has the potential to provide us algorithms as a service. So we have machine learning algorithms already streamlined in a way that is very easy to connect them to data sets and extract relevant information from them. And the way that we do this integration and we build the systems that are going to assess and optimize the energy in buildings, we need to remember that we are building systems for humans. And the purpose of using machine learning in these systems is because we have so much data. And I'm using this representation of Ackoff's knowledge pyramid. And you see, data is not much more than symbols. And when you have a huge amount of data, it is represented there in the lowest layer of this pyramid. Data itself doesn't tell you much. So that's where machine learning can help you. It can process this data to extract useful information that you can then use to make decisions or even to build automated services that will operate building energy systems in an automated way. So the first layers of this pyramid, using simple methods, you can extract the who, what, where, and when from the data, and then use this information to go a bit beyond this first level to a more explanatory level of algorithms, which tell you the how and the why. And these are very important for energy assessment in buildings, because they bring you diagnoses that will really help you in making decisions on how to operate the energy in buildings. And of course, they bring more meaning to humans. So which kind of applications can machine learning have in the context of buildings? Well, it can be used for monitoring and assess energy, both the consumption, load disaggregation, so that you can find out how the energy is being used by different consuming devices. It can be used for prediction, and prediction can be prediction of consumption and prediction of other factors that are affecting consumption, such as the weather, such as the occupancy of the building, all factors that are related to the way we consume energy. You have to know that energy assessment is not making or having measurements of energy consumption in devices in buildings and displaying these measurements. We need to go beyond that so that we can assess the performance of those devices and the performance of the buildings. And to do that, we need models, we need different processing capabilities. So, but coming back to these applications, you have demand response optimization, fault diagnosis, thermal control or thermal comfort control, indoor environmental quality control. It can also include thermal control in there, also with air quality and the lighting control, which are three domains, at least these three of IEQ. Control of flexibility of distributed energy resources, and of course, importantly, because this involves the occupants, the owners, the users of the buildings, we need to have cybersecurity and privacy, and machine learning here also have important roles to fulfill. What is the general approach that we have for to have machine learning based buildings energy assessment? Well, first let's define self-assessment, which is the concept that we use in the project. And we define it as the capability of a building energy system or equipment to self-diagnose their energy performance. So what we build is we have the device and we have data measured from the device and the environment in which the device is operating. And we create like a virtual device in the cloud that we can, that becomes the self of that device, and it can assess itself and optimize itself. This is the principle behind our project. And so we envision machine learning based self-assessment of buildings energy performance. And we see it operating in two ways. And these two ways are related to the way we use data. We can use it in a passive way, and I'm going to explain a bit what is this passive way of using data, or use it in an active way of generating data for the assessment. So passive usage data is just, we have lots of sensors and we have devices that use energy transmitting information to the cloud. Data is being continuously generated and stored in the cloud, and it is also being continuously processed, analyzed. We also have a definition of what to expect from those devices, from those buildings. Let's say we have benchmarks, we have performance thresholds to compare our assessments to, so that we can find out, is the performance good or bad? We need these references. And this is the first 2 points in the passive usage of data. On the active side, we are going to use the controls that we have in the buildings to generate data in a controlled way that we can, by which we create assessment scenarios to extract important performance indicators from the devices or from the building. But for that, we need to control the building, let's say to excite, to gear the building to a certain operational point where we can then measure data, and using models that we fit using machine learning to extract parameters and baselines that will be very important on the assessment. Whether it comes from the passive way, just by measuring and looking, analyzing, or from data that we actively generated using the building and the devices that are in the building, we then try to find deviations and to explain these deviations to the performance of the equipment or of the building. And this is the path from going through data to these explanations and to find these deviations is the main role of machine learning here. Because you have too many data and you have to summarize it into this useful information so that automated systems or humans can make informed decisions and high quality decisions on how to manage the energy in the building. Then in these self-assessments that we have, we are going to project them and to analyze them in different scales: space, time, occupancy of the building, and also autonomy. And this is the way autonomy is to assess the way that management services operate. Are they fully automated or completely manual? And we can project the assessments on all these scales. There are 4 main assessment categories that we are going to perform in project: energy related, usage related, assessments related to the way we use the energy, functionality assessments, and then fault assessment in the equipment that we have there. This is a list of examples of assessments that we can do on the building. I'm not going to go through all of them. Maybe energy people that are related to the energy field already recognize here different, but there are many other assessments that we can do, provided we have the right data for that. I think I'm going to finish now with just 2 or 3 more slides, just to talk a bit about the main types of problems and the challenges that machine learning-based buildings energy assessment face. And so, what are the main problems in this context? Well, they can be categorized in modeling and simulation problems, control problems, or optimization problems. Modeling and simulation, we are going to use machine learning techniques to perform system simulation, to make predictive models for the weather, for the consumption, for the occupancy of the building, different kinds of models that will generate predictions of performance indicators or forecasts of quantities over time. And of course, classification is also an important kind of technique that we are going to use here. Then these can also be used for control, and the model predictive approach is central and is considered to be the most effective way to use data and assessments then to find, let's say, an optimal way to manage different devices in the building. And of course, optimization, machine learning based optimization methods, they can take complex problems that are that have high dimensional data. These are usually called meta heuristics because they can handle problems that usually with more classical optimization methods you would be able to solve these problems with. Main challenges, and this is an important point. I think this is not the last slide, but the previous one. I'm not sure if I'm taking too much time already.
It would be good to conclude, Pedro.
All right, so I will. People usually have a high hope on artificial intelligence and machine learning, but they forget that it is very difficult to make these systems operating correctly in practice. Why? Because usually it is difficult to maintain data quality and data dependability. This is related to the data availability, its reliability, integrity, and so on. So it's common to have sensor failures, missing values, and we need methods that operate well when these kinds of problems occur. And this is not common. So in academia, we have data that is very well cured. It's very well processed and stored. And we build very good methods that operate very well on that data. But commonly, in a real scenario, this will not be the case. And we have to be able to cope with sensor failures, device failure, missing values, so on. Then there is scalability. Is my method, my solution good to be scaled to millions or to many thousands? Is it scalable? If it's not scalable, then there's no point in developing. And then there is the user. The user has the potential to mess up things a lot if your system is not well designed, let's say. And the difficulties here have to do with how to catch the preferences of the users and how to maintain their satisfaction with the operation of the system. This is a real, at least this second part is a real challenge. And of course, we need to have systems that are non-intrusive. We don't want to be nudging, I'm going to use that word, nudging the users all the time, bothering the users all the time. It needs to be done with parsimony. The last slide, okay. And I think this is, for me, this is the big challenge that we have. And how can I use machine learning, statistical learning, artificial intelligence, call it whatever you want? Because the problem is that all these different systems exist in buildings. You want to manage demand response, flexibility, indoor environmental quality, thermal comfort, lighting, air quality. You might need to ventilate. You want to have good energy efficiency. You want to have electrical vehicles also using energy. You have PV production in your building. How do you manage? Because some of these things, they are in conflict. The objectives individually, looking individually at each one of these aspects, they might be conflicting with each other at a certain point in time. Then how do you optimize and manage these systems? And I just want to give an example on how artificial intelligence agents that were based on a technique called reinforcement learning and deep learning models, artificial neural networks, that were used to develop agents that just by looking at the pixels of the screen of classical arcade games that are very complex games, and it's very difficult to win. And these systems, just by looking at the pixels and knowing their performance, they manage to win and to beat the records of these games after some time, after learning. So, and these are very complex problems. So if this can be done in this area, I'm sure we can also use these techniques or similar ones using machine learning to provide an acceptable machine learning based system that can manage the energy resources of a building in a holistic way and in a way that satisfies the requirements of the involved stakeholders there. And that's it. Thank you for listening. And of course, I will be happy to take your questions as soon as the time comes. Thank you very much.
Thank you, Pedro. It was a nice explanation of how building self-assessment and energy assessment is important. And now we'll move to Manuel Casquiço and the presentation about public administration retrofit plans and the current reality in Portugal.
Because I have the sound.
No, it's okay. No, it's not. Okay.
It's okay now?
Yeah, now it's perfect.
Sorry for this. Okay, thank you very much. I'd like to thank you to EDP New for the invitation for us, for Adrian to be here, talk about some projects about public administration, about buildings of public administration. So I will talk about three different simplex measures that we are implementing at ADN. Simplex is a wider program of simplifying processes in public administration in Portugal, and we have funding support for implementing these schemes. The first project, it's the process, it's the ECO.AP process, because we are talking about the program, the wider program of energy or efficiency resources in public administration. Next, we have the Aqua Monitor, is related with water losses. And finally, we have the POP Energia, it's related with its Save Energy, it's related with the open market of electricity and natural gas. So all these projects are related, I will explain how. So the first one, it's the Resource Efficiency Program in Public Administration. This program already have 10 years, so it started in 2011, and in 2020 we have a new legislation into force. So it brings to the program other type of resources. We are talking about water, we are talking about paper, plastic, fleets in vehicles, so all different aspects that all the public entities must be aware of, okay? And this program, it's a wider, it's part of two wider programs that are the Roadmap to Carbon Neutrality and the National Plan for Energy and Climate that you can check on this legislation that is in this slide. So the importance of this program is that it brings targets for the public entities. So we have here 5 different targets for public entities. 40% of reduction of primary energy consumption, 10% self-consumption in renewable sources, 20% of reduction of water consumption, 20% reduction of materials consumption, and finally, a rate. It brings a rate for refurbishment for the public building. So it's very important, and these are the targets that all the entities must have when they are making their plans. I will explain later how. So this is some numbers just for you to know the universe that we are talking about. So in Portugal, we have 19 governmental areas. So each area has an energy and resource coordinator that is our focal point for the ECO.AP program. Okay, we talk to them and we send them reports about this program for them to check how is the evolution going in the governmental area. We have more than 1,300 entities. This is the approximate number, and we are talking about 20,000 buildings and infrastructures of the different types of governmental areas, defense, education. So it's a wider program that it brings together different types of buildings, and that is one of the challenges of the program. So we have here several activities that we are doing at our department. So the first one, it's the barometer ECO.AP. So it's an online tool that each entity have access to control all aspects of their buildings, and they can go there to check electricity, natural gas, and all the information, and they can control all data there. So the other one, it's the ECO.AP web. It's a one-stop shop that we are doing for public administration. It is the first one, the barometer, is already into force. The second one, the web ECO.AP, we are developing at this moment. Another important aspect, it's the efficiency plans, as I said before. Each entity must develop an efficiency plan until the end of this year. So we are helping these entities, all the public entities, more than 1,000 entities, to try to develop their efficiency plans that will help them support the financial scheme of the ECO.AP program. So we are hoping that in the next 2 months, I think in this month, we are going to have a financing scheme with the European funds to implement the energy efficiency measures for the public administration. So it's a specific scheme for the public administration, and ECO.AP, it's an important part because we are giving support to these entities. Another activity that we are doing, it's training activities. So during the year, then we have several training activities that we are doing to support all these entities. We are also making dissemination because we want to be a good example, a role model for service buildings, for public buildings. You can check our LinkedIn account. We also developed support tools. So we have different types of simulators that entities can use to, for example, to test and to try different types of energy efficiency measures, and they can see the payback period, they can see the savings, so lots of information. And we also have technical support. We give technical support and make energy audits for different entities. And we also don't work only in Portugal. We also work with other countries, for example, with Cabo Verde. Okay, this is a Portuguese language country that we also work with them. So one of the information that we can extract from the barometer ECO.AP, it's the electricity consumption. So this is one example of the information that we can extract, and it's the information that we are using for another project that we have regarding data science and artificial intelligence. So what we are doing here, we have information about electricity consumptions from 2014, and each year we can see the consumption, and in this case are these 1,675 installations, because these are the installations that we have detailed in our platform. So we can see what is the increasing, what is the variation, and we can see what is the problem in why this happens. So we have a project that we are working on specifically just to see what is the problem, what happened, and to send a trigger, to send an information for our contact point in the entity, and to see if the information is correct or not. So other indications that we have are regarding, for example, some indications that help to see if the different targets are being fulfilled. For example, consumption per area, per user, and other costs. So this information we also have in our platform, And just for we send a report each year, for example, for each of the coordinators of each governmental area for them to see how is the evolution. Another important information for us to cross information, cross data, is regarding building energy certification system. So as you can see here, it's the current energy rate, just for you to have an idea. These are public buildings, central public buildings. We have the rates, the new energy rates after the implementation of energy efficiency measures. And you can see the different type of energy efficiency measures with the focus on lighting, because of course it's one of the easiest measures to implement. And here you have the average investment per building. So this is for you to have an idea of the amount of investment that is predicted for this kind of buildings. One of the other projects that I already said, it's the Aqua Monitor. So Aqua Monitor, it's going to be inserted in the barometer. It's specifically for water saving. So we also, for the different types of entities in different type of buildings, we are going to control also the water consumptions. And we already have a pilot that say to us that we can have a potential savings up to 35%. So this is a very important project for us. These are different types of models that we are developing. We also are using artificial intelligence also here and machine learning also to develop this project. So this is a different phases. I think the professor before already talked about some of the important phases of the artificial intelligence, but this is just for you to have an idea. The great objective in the end is to have an alarm that will help the different local energy managers to see how the building is going, what is the variations, and to help them to have activities to implement measures to make a reduction of the water consumption. The other two different projects that we are working, I will not talk about this one. It's about energy poverty. It's also an important project that we have. Are the projects related with data science, specifically with the energy consumption. The first one is specifically for ECO.AP, just to have an alarm also based on the profile consumption each month for each one of the buildings. So the idea is with machine learning and also with artificial intelligence to see the variations in the profile, and then to see what kind of measures will be or have been implemented in the buildings. So the idea is to check variations and to send alarms and to send reports for the managers and of course for us, for the different coordinators of the different governmental areas to see what is being implemented. So other aspect, and finally, this is the last slide, it's the POP Energia. This is important because POP Energia is related with the open market of electricity. We are now helping also the entities to understand what is the best tariff for them and also to see the costs of the electricity bill. So it's another project that we are also developing, not only based on, as you know, the fixed tariff, but also in the indexed tariff we have in the market. So the idea is to evaluate and also to propose different tariffs and to help the public entities to promote energy efficiency, of course, to reduce costs in the end. Basically, this is the project. So this is my presentation. Of course, if you have some questions, I will gladly to answer to them. Thank you very much.
Thank you, Manuel. We'll now move for the Q&A session. We already have some questions on the the chat, so we'll move to these questions. The first one I think is directed to Philippe, and it says, now the chat is loading, not cooperating. Okay, I have access to it. Says that the platform is really interesting, but how do you tackle the integration with existing equipment, and how are you planning to accelerate the adoption of your platform to customers with existing equipment? I think this is a really interesting question, and to complement, how are you looking for a possible business proposal for this, and will it take into account any initiatives for adoption?
Thank you, João. Yeah, let's try to break down the question. So regarding the first part on the integration of different equipment, Basically, the platform, as I told during the presentation, it is an interoperable platform. This means that we aim to collect data from several systems, but I guess that if you have proprietary systems, such as remember, for example, the KNX systems usually are proprietary, so this will be harder to integrate into these systems. So, well, of course, we need to have open source or types of systems that allow us to do this integration, or have at least an API or some method of doing this. But there are some limitations to it, of course. Then the second part was the business proposal, that we can, if we have any possible business proposal, and we'll take into account any incentive for its adoption. Right now is no, we are not taking into account any incentive. Basically, we are trying to study what will be the value that we can obtain for this. One example that I can give you is that Siemens, which is also a partner of the consortium, has systems that integrate on large buildings that have this smart layer, this smart evaluation, and they can achieve savings up to 30% in some buildings. So if we can achieve that scale of savings in smaller buildings, then we can recover our investment very quickly. If we have less value, if we don't achieve such savings, then it will be a bit harder to get the value back, have a payback period which is longer. But anyway, this, like I was saying, this is a testing phase, and after the testing phase, we'll address if this is economical viable or not, or what will be the strategy to put this on the market.
Okay, thank you, Flip. We have two questions for Pedro. The first one is related with 5G, asked by Luis Guilherme, which say that 5G will play a key role in this technology and is concerned about the impact of these systems on public health. Are you thinking to address this issue? And the second question, also for Pedro, on another topic, is what's the most valuable machine learning technique for energy building sector today, and why?
Okay, thanks for the questions. The first one, I'm going to be honest, I'm not thinking on how to address this issue, and honestly, I don't think there is an issue. So, in part because in many of our buildings, the technology that is going to be used might or not be 5G. I think before we have a large predominance of 5G within devices, gadgets in our houses, it will take some time. And maybe for these kinds of environments in our house, if we have a single internet connectivity point, there are other technologies to communicate within the house which are well established already. There is no point to have 5G in each of our own devices. They might solve 5G might solve other problems at larger buildings and locations of difficult accessibility, things like that. But honestly, I also don't think that 5G will be or is a health problem. Regarding the second question, what's the most valuable MEL technique for the energy building sector? First, I don't think there is a single technique that is more valuable than others. They all have different purpose. And in energy assessment, there is, or even in optimization of the energy resources, there are problems where the most common techniques, I'm going to say, modeling, classification, clustering, they are all important. I can tell you that probably one that is, but then it is just because artificial neural networks are, I think, the most generic machine learning technique that can be applied to a big, a plethora of different kinds of problems. It's very versatile. It has been applied in many different application fields, engineering or not. So it's probably the most versatile one, because with a neural network, you can actually perform clustering, you can actually perform classification, you can do forecasting, you can predict quantities. So it's highly reliable. And so for that reason, if I had to choose, if from my machine learning Swiss Army knife, I had to choose only one tool, I would choose the neural network. But if I have the freedom to choose the right tool for the right problem, then I wouldn't go only with artificial neural networks. I would use other methods for specific purposes, depending on the problem that we are addressing at a certain point. Okay, and of course you mentioned supervised learning, reinforced learning. I call these, or unsupervised learning, I call these approaches. Then the techniques are specific techniques that we have within each of those approaches. I think that's my opinion on this matter.
Thank you, and I think it was a really complete discussion.
I hope so.
So a lot of information was passed. We also have a question for Manuel, which asks, compared with other European countries, how would you rank Portuguese public buildings in terms of energy efficiency? And perhaps we can try to add another layer. How can we? How is the funding available, trying to bridge this gap?
Okay, thank you very much for the question. So this is a difficult question. I will explain why. Because the public administration, we have different types of buildings, and of course different type of governmental areas. I will give you, for example, the example of the defense minister, the area of the defense. So they are very well aware of these questions, and one of they are always trying to implement energy efficiency measures. And if I have to rank, I will say that the defense, this governmental area, certainly with our colleagues from European Union, they are on the top layer of this rate. Okay, but are other type of governmental areas that don't have the same technical support, so it's very difficult for them to implement these energy efficiency measures or to have energy efficiency plans without support, for example, from an entity from ADEN. So what I'm trying to say is that we have different type of examples on the public administration. So we have, of course, areas that are very aware of this type of energy efficiency measures and resources, and we have other areas that are not. And we are trying with the funding. That's another good question. But with this funding that are coming, we are trying to help these entities that don't have the technical support because they don't have the same type of technicians on the entities to level up, okay, where they are, in trying to bridge this gap that we have at that moment. But to be honest, we have some governmental areas that are quite well, and they are quite interested, and they have all the information they need, and they also have their systems. I can give you another example of our health governmental area, our health minister. They have their specific platform where they can control resources, emissions. So we have, as I said before, different type of areas and different type of resources. Just to final, it's just to say that of course the financing schemes will be very helpful for us, just because they will give this leverage for these kind of entities. And I think in the near future we are going to have much more energy efficiency measures implemented.
Thank you, Manuel. Just we have another question, which we already replied a little bit, but do you think the energy efficiency should have received a bigger part of the funds from the coming PRR program, Programa de Recuperação e Resiliência?
Well, that's also a different question because, of course,
Yeah.
everyone wants the money. What I can say is that if you have any energy efficiency measures and you make the audits and you can know what is the payback period, some of the measures are very good for the implementation. We are talking about, for example, PV panels that at this moment it's getting very interesting from the Portuguese consumers. And for example, lighting, as I said before, for example, local municipalities, they are making lots of contracts regarding lighting. So what I'm saying is that if the energy efficiency measure it's well calculated, of course it will pay for himself for the measure. So I don't think that it's a demand to have more money for this kind of projects. So if things are well analyzed, well studied, I think the measures can be implemented without the funding. Okay.
I think João had some issue, but I think that we concluded now the questions. So I would pass, thank you very much for all that were here, and I would pass the word to Monica to conclude this session. Monica, you're muted.
Sorry. Thank you, Philippe. We just reached to the end of this session. I want to thank you all for the ones that enabled to have a webinar like this. Firstly, our speakers, thank you very much for your availability and for your time and for being able to be here and share with us your knowledge. Secondly, I want to thank to the team that helped us to organize the webinar, mainly Felipe Silva, José Miguel Costa, and João Bravo Dias. And last but not least, of course, want to thank to our attendees for being here and for following us in every webinar that we organize. So make sure we don't miss the next webinar. It will be another webinar in the topic of the energy sector and with some surprises and changes. So make sure you don't miss it. And that's all for today. Thank you all, and I wish you all a good afternoon. Bye-bye. Thanks.